Welcome back everyone to the eCoreAcademy learning platform. My name is AJay Raj, back with yet another Algebra 1 video for you all. And in today's lesson, we're going to be covering the multiplying and the multiplication of polynomials. Now, this is an essential topic in Algebra 1, so please make sure to stay tuned. Before we get into the lesson, please make sure to do 4 things. Hit that subscribe button, hit that like button on this video, turn on post notifications, and leave a comment down below. All 4 of those things are really greatly appreciated. Now, as I was saying, the topic of this lesson is going to be revolved around the processes involved in multiplying polynomials and their special cases. Now, if you haven't already, gone over polynomials, or if you're not familiar with them, please make sure to look at our previous videos on polynomials, the structure of them, and also adding them. So that'll give you a basic overview of what polynomials are and exactly what you can do with them in terms of operations. So this is what we're going to be doing, advancing into the next level of multiplication. So we'll take a look at the first of 2 special case scenarios that you'll be coming across in Algebra 1 specifically. There are more complex ones that you'll come across in Algebra 2, but in Algebra 1, there's 2 main multiplication incidences, and that's going to be squaring a binomial, and then the next one will be multiplying conjugates. So we're going to start with squaring a binomial. And this is where the famous FOIL method essentially comes from. FOIL as in like aluminum foil, literally. But it's an acronym, obviously. So when squaring a binomial in the form of a plus b, so two terms that can be like a can be either x and b could maybe be an integer. When you're putting that in the form of a plus b squared, so you're multiplying it by itself, the common misconception is to square each individual term and leave it as your answer. However, instead, you must multiply out each individual binomial expression using the FOIL method. So if you think about this a plus b here, say for example, and we were to put that squared value here, I think many individuals, what they would think is it's going to equal a squared plus b squared. And that's the common misconception. However, you're literally multiplying a plus b by itself twice. So you're multiplying by the whole expression a plus b. So it's not just going to be 2 terms, it's going to be 3. So instead of a binomial a squared plus b squared, that is still going to be part of it. It's going to be a trinomial with an extra middle term. And now for the FOIL method, just an acronym, it means first, inner, outer, last. And I'll show you what that means when we're multiplying these binomials out, squaring them. So let's take a look at some practice. Let's square the following binomial. So you have the binomial x plus 3 squared. So that's written in the form of a plus b. X is taking the form of a, and then 3 is taking the form of b. So now if we were to write that out, what we would do is the first step is to make sure we essentially write it out full form. So x plus 3 squared, anything squared is that value multiplied by itself. So it's just going to be x plus 3 times another x plus 3. That's all it is. Now that we've gotten to this step here, what we're going to do is we're going to use the FOIL method. Now f here is going to be our first term. So we're going to multiply the first terms of each expression first. So that's going to be x and x. So when we multiply those together, we get x squared. Remember, we want to make sure that we get to all variants of each value from the left-hand side expression being multiplied to each value on the right-hand side expression to make the full entire expanded form. So we have x and x multiplied with each other. Now, the next step is to take the outer terms, the 2 outermost terms, and then multiply those together. So here we have 3 and 3 as our outermost terms. We're left with 3 squared, essentially 3 times 3, and that's going to be 9. So that's where we got the common misconception of a squared plus b squared. We've got there. That's still part of our answer, x squared plus 9. However, there's 2 middle terms that you're not counting for. We have to now multiply the inner, the innermost terms, and then the last terms, essentially. So you have these innermost terms. That's going to be 3 and x. Those 2 are on the very interior. And then the last is going to be the outermost terms. So that's going to be x and 3. So now you're multiplying 3, you multiplied 3 by 3. Now you have to multiply 3 by the other term. Same thing with x. You already multiplied x with x. You have to multiply with the other 3 now. So when you do that, you're going to get 3 times x here. That's going to equal 3x. And then also when you multiply x times 3 over here, you're also going to get 3x. Now if we simplify that out, we're going to be left with x squared, and remember, writing in proper polynomial notation, plus 6x plus 9. This is going to be our final answer, expanded out. Now, what is a common way to write this? Well, whenever you're squaring, your binomials here, a plus b squared, you can always write this as a shortcut. Whenever you see a binomial being squared, you can always go to the shortcut of a squared plus 2ab plus b squared. That's what your answer is going to be. Now, we can prove that with our given problem here. So we take x here, x plus 3 squared. We're going to take x, we're going to square x, that equals x squared, so that works. We're going to take our, it's saying 2ab, so we're going to multiply b times a, that's 3x. We're going to multiply that by 2. We get our middle term, which is 6x. And then our last term is going to be b squared, so 3 squared, and that does indeed equal 9. So that is the shortcut to this process, if you ever get stuck. And now on to our second special case. We have the product of conjugates, so that's the sum and difference. So this is the product of conjugates is actually fairly simple, although its name might be a little bit intimidating. So the product of conjugates involves a multiplication of two of the same binomials, except that one is a subtraction of both terms and the other is an addition of both terms. So you'll still use the FOIL method in this process as always, but just like our squaring of binomial, there will always be a shortcut to the answer. So essentially what a product of conjugates, this is the theorem is going to look like. The product of conjugates, these are basically the same exact expressions. They have the same terms for A and B. However, one is being added together. These two terms are going to be added together. The other one's going to be subtracting it. And you're going to multiply those together to get your final answer, which is just A squared minus B squared. So that's the shortened form. If you ever notice that you have, say for example, x plus 3 times x minus 3, well you know to go straight to a squared minus b squared. But of course we're going to prove that. So let's multiply the following conjugates out. So we're given this equation, y equals x minus 5 times x plus 5. Now in this equation we're going to use the FOIL method just to prove it, and then we're going to check how the conjugate theorem actually spells out. So we'll start with our FOIL method. Just write that out on the side. Always useful. We'll go with x minus 5 times x plus 5. We'll go with our first terms, x and x, left with x squared. Then our outermost terms, negative 5 and 5. That's going to be our negative 25. Then we're going to be doing our innermost terms over here. That's going to be negative 5 and x. So that's negative 5x. And then our outermost terms, whatever terms are on toward the outside, that's going to be x times 5. So it's just this. It's just the opposite sign. So it's plus 5x. Now, if we were to simplify this out, we would be left with, just to show you the calculation, x squared minus 25. Nothing cancels out there, but we notice that negative 5x and 5x, those two are going to cancel. So we're left with x squared minus 25, and that is exactly where the conjugate theorem comes into play. It's just a shortened version of getting here, because if we prove that here, we prove that over here, we know that it's going to be our a squared minus b squared. Our a values are x and x, so if we square them, we're going to get our x squared right here, and then our negative 5 and 5, it's just going to be your it's going to be your b squared value or b value, which is 5 in this case. You're going to ignore that sign. It's 5 in this case. So you're going to square it, you get 25, and you're subtracting it from x squared. So that's where this a squared minus b squared theorem comes from. So just keep those in mind if you ever get stuck, or if you want to be more efficient on a test, because I know a lot of tests in high school, they're a lot more strict with the timings, so you can definitely save yourself some time. All right, everyone. Well, I hope you guys enjoyed this video. Pretty simple video, but I think it'll definitely be useful in setting us up for future lessons. So please make sure to like and subscribe down below. Turn on post notifications. Leave the comment down below. All that stuff. Check out our website at www.eCoreAcademy.org. See what kind of new interesting content we have out there. You can email us if you have any questions or if you just want to reach out to us. And also check out all of our social media platforms down in the description box below. All of those things are greatly appreciated. Once again, this has been AJay Raj, and I'll see you guys in the next one. Peace.